Hello everybody. This lesson is covering the quadratic variation. So we've already talked about inverse variation. Quadratic variation is very similar, and the equation that we're going to use, the process that we're going to use for solving is also very similar. In looking at the notes sheet that I provided, this is the screen capture of the quadratic variation piece. You can see that the equations are very similar to what inverse variation was. When you have f of x equals k times x squared, inverse variation didn't have an x squared. Quadratic variation uses x squared. So we want to take our x value, our input value, and square it. And the difference in the graphs, these graphs have a curved graph. And then it helps to remember that the output, so your y value, the outputs are your y values, vary directly with your input squared. Inputs are your x values. So make sure you have your notes sheet handy for this. Everything that you do for the quadratic variation lesson is very similar to what you did for the the direct variation lesson. So if you're trying to determine if something is a quadratic variation, they're going to also share that same constant value. So every ordered pair in this table should have the same value of k if it is a quadratic variation. If k is not the same for each ordered pair, then this would not be a quadratic variation. So the equations that you use to determine a quadratic variation, you have the f of x equals k times x squared. And if we want to find k, if we're specifically solving for k, if we were to divide by x squared, we would have k by itself. So we would end up with f of x divided by x squared, and that equals k. This is going to determine k for us in this relation. So for this first one, notice that it has y instead of f of x. Y is the same as f of x. They're both the output values. So for this first ordered pair, 3 over 1, or the x value is 1, the y value is 3. If we're finding k, we want f of x over x squared. Well, our f of x value is 3, so 3 divided by x squared divided by 1 squared. This one comes out to equal 3 because 1 squared is just 1. So this one's solved to equal 3. So if this is a quadratic variation, each of these, when I calculate out k, should be the same. So if I try this one, my f of x value is 16. My x value is 2, so divided by 2 squared. This simplifies to 16 divided by 2 squared, which is 4. This one comes out to be 4. So right now I can see that the first time my k value equaled 3, the second time my k value equaled 4. Since these numbers don't match, this one is not a quadratic variation. So you can keep going to calculate out all of the k values, but you wouldn't have to because we already determined that the k's don't match. If you calculated this out and all of these got the exact same number, then it would be a quadratic variation. But because they're different, k is a constant value, and if it's different, it's not a quadratic variation. Another way to determine if something is a quadratic variation is to look at the actual equation. Our quadratic variation equation that we're using is f of x equals our constant value times x squared. And this constant value should be a number. So our equation should look like this. It should look like f of x, or y, equaling a number times x squared. So in looking at this equation, it looks similar. We have 4y, so 4 times y equaling 3 times x squared. But over here, there's not a number in front of f of x. But we're not quite done. In looking at this example, I see that there would be a way to get this y by itself. Right now, this is 4 times y. The opposite of multiplying by 4 would be if I were to divide by 4. So let's try this first. If I divided both sides by 4, these 4's cancel off. We have our y by itself. Again, y is the same as f of x. So y equals 3/4 times x squared. Now my equation matches my quadratic variation equation. I can clearly see that it's f of x equals a number times x squared. Down here we have y. Again, y is the same as f of x, so y equals a number 3/4 times x squared. So this one actually is a quadratic variation because it's in the quadratic variation equation. It's set up the right way. So other similar problems with direct variation, they gave us a statement saying that there was a direct variation and that they wanted us to find a new value. So there's similar problems with quadratic variation. They're telling us in this example that there is a quadratic variation between the two values. So between f of x and x, so f of x being 18 and x being 6, this relationship here has a quadratic variation. So in order to work with it, we want to figure out what the constant value is between those. So our first step is to find k. And to find k, we were using k equals f of x over x squared. Don't forget the squared piece. A lot of students forget that it's a squared value for x. If you don't square it, then you're working with direct variation and it's a linear equation. So it's very important not to forget that you want to square that x value. So let's find k between this quadratic variation. So k equals our f of x value, 18, divided by our x value, 6 squared. And if we simplify this, we would have k equals 18 over 36. 6 squared is 36. And k reduces down to 1/2. It's a lot easier to work with a simplified fraction. So in this entire problem, the constant value that we're going to use is k equals 1/2. So now to answer the second part of the question, find the value of f of 8. This means you're evaluating the function when x equals 8. So using our quadratic variation equation, f of x equals k times x squared, we know that k is 1/2. So our equation that we're going to use for this problem is 1/2 times x squared. So now we can replace x with 8. So f of 8 equals 1/2 times 8 squared. Again, don't forget to square that x value. So f of 8 equals 1/2 times 64. And f of 8, when you actually multiply 1/2 times 64, you end up with f of 8 equaling 32. So when x equals 8, the f of 8 value is 32 for this quadratic variation. And it helps to go through these steps. So our step 1, when we first found k, we figured out that k equals 1/2. Our second step, we set up our equation. This is step number 2 here. And then our third step was to solve for the new value. So we substituted in that value of 8 here. We can also graph quadratic variations. Again, their graphs are curves. So to graph this one, y varies directly with x squared, and y equals 8 when x equals 2. So it's similar to the problems we just did. We have to first find k. So step 1, find k. We use our quadratic variation equation for k, where k equals our f of x value divided by x squared. And our f of x value is 8 because y and f of x are the same. So 8 over our x value of 2, so 2 squared. This simplifies to 8 over 4, and we get 2. So our k value, k equals 2 for this relation. So now to finish filling out our table, we want to use our quadratic variation equation. So our y value, y equals k times x squared. Again, y and f of x are the same. So we found k to be 2. So y equals 2 times x squared is the equation that we're going to use for each of these x values. So if you substitute in -3 for x, you would have 2 times a -3 squared. So that -3 squared is 9. 2 times 9, we get out 18. If we do it with the second one, we would have 2 times a -2 squared. -2 squared is 4. -2 times -2 is 4, so 2 times 4 is 8. Substituting in -1, 2 times a -1 squared. -1 times -1 is 2. 2 times 2 is 4. And if you continue this process, substituting in these values, this one comes out to be 2 times 0, so 0. 2 times 1 squared. 1 squared is 1, so 2 times 1 is 2. 2 times 2 squared. 2 times 2 squared is 4, so we end up with 8. And then this last one, multiplying it in, we get 18. So now we have a set of ordered pairs that can be graphed. With our graph, so this is the same table, just typed out, we can graph each of these points. So -3, 18 is a little off of our graph, but that's okay. Is up here, -2, 8, -1, 2, 0, 0, 1, 2, 2, 8, and I feel like on my previous one I had a mistake. This one here, -1 squared is 1. This should be 2. And then 2, 8 we did, and 3, 18. So you'll notice that your points are similar. And this is the tricky part with working in Blackboard. It's hard to do my graph pretty. So I'm going to try, but you will get this curved graph for quadratic variation.